Hi everyone. This video is about the question of what the magnetic field looks like around a current carrying coil. On the right side of the table we examine the magnetic field of a bar magnet with the help of a compass. On the left side there is a coil that is connected to a power supply unit. If we switch on the power supply and we increase the voltage, current flows through the coil. Now we can examine the magnetic field around the coil with a compass here too. In the animation we compare the different orientations of the compass needle at different positions around the bar magnet and the coil. We find that the magnetic field around a bar magnet and the magnetic field around a coil have the same basic shape. So, if current flows through a coil, you can easily imagine that you are holding a bar magnet in your hand. How does the shape of the magnetic field around the coil come about? Let's take a look at the flow direction of the electrons through the coil. The electrons flow from the negative pole of the power supply unit into the upper side of the coil. Then they flow in a circle 600 times until they flow over the red cable to the positive pole of the power supply unit. Let's take pieces of wire out of the front of the coil as an example. From our point of view, the electrons flow upwards through the front. To determine the shape of the magnetic field, we use the left hand again. The thumb points in the flow direction of the electrons and the remaining fingers indicate the direction of the magnetic field. All wire pieces on this front side form a magnetic field with the following simplified form. Now the magnetic fields come through the other sides of the coil. Together, this results in a three-dimensional magnetic field of a bar magnet.